Okay, so here we are back in the Word document, and I'm going to paste that graph in. So it opened up in Paint. That's the only thing you didn't get to see. And then I just selected it and hit copy, and then I pasted it in. Let me shrink it so it actually fits. I do have some of these text boxes in your document just to make things fit. So if you hate them, delete them, that's fine. But I want this one, this graph in front of me here while I do the rest of this problem. Okay, so here I'm going to actually snag this and move it over because it's annoying to have it here. We have a few questions to answer. There we go. All right, so here's our graph in front of us. The first thing we're supposed to talk about is domain and range. So I don't always use the word associated range, but I wanted to say it here to make sure that was a really clear thing. So reasonable domain and range is not a perfect science. You sometimes just have to use a little bit of common sense or intuition about the situation to decide that. What I would say is your reasonable domain should not just be whatever the minimum hours waitlist and maximum hours waitlist were. So remember, domain is the inputs or the X values. In this case, that's hours. So we want to talk about for what times does this model seem like it would be reasonable? And I would say, based on what we're looking at, it does seem like the linear model is reasonable. So probably we can go all the way back to 0. I don't see a reason why not. I'm not expecting you to be an expert on reaction time. So I would say I can probably go all the way back to 0 hours. I'm not going to want to go forever because maybe at some point this pattern doesn't just continue being linear. So we definitely want to go out past our 14, but maybe we don't want to go crazy far. It's a reasonably good fit. So let's say we're going to go 0 to 20. And again, there's not one perfect answer here. We're just kind of thinking about what would be unreasonable and making sure we're leaving that out. Okay, so reasonable domain, I would say 0. Here, let me move that over. It always wants to center it, so you can either just arrow out and put some text on the line and it'll quit, or you can leave it centered, but it always puts equation stuff centered. Okay, so we went 0, less than or equal to, and you just hit exactly that, the less than and then the equal to, and it formats it quite nicely. And then what did we use? H for hours, less than or equal to 20. Okay, so the thing that I want to make a big deal about here is that for range, you can't just look at this picture and arbitrarily choose that you want your range to be everything from 0 to 3. Once you pick a domain, or even vice versa, if you pick your range first, you have to make sure that these two match up. These are going to be like XY pairs for this graph. So you have to actually find the point on the graph that has the h coordinate 0 and the point that has the h coordinate 20, and use those to figure out what your minimum and maximum are. So one of those is easy. Oh, I didn't type our model in here. Let me type it right up here so that we have it in front of us. Okay, so just reading the numbers that were in Desmos, we got that t was equal to 0.13h plus 0.16. I used a little t in Desmos, but as I flip back here, I see that I used big T, so I stuck with that. And you can even throw in your function notation if you want. So it's a t of h. I'm going to color this so that it's easy to spot as we're working. What do we want? Maybe like bright green? Oh, that didn't color the whole thing. Bright green. Okay, so there's our model. So when h is 0, we're talking about the y-intercept. So the minimum y value, or big T value, that we're going to get here is 0.16, and there is a little bit of rounding happening there, and that's okay. These are models, they're not going to be perfect. So try and keep some information. I generally try and keep at least a couple of decimal places, but it's okay if it's not perfect. And then to get that maximum value that we're going to use, you don't even need to estimate from this graph. You can actually use your equation. So this equation right here, I'm going to take that 0.13, and then I'm going to multiply by my h, which in this case is 20. That's what we chose for a cutoff. And then I'm going to add that 0.16, and I get 2.76. So the biggest t value that we're going to get, oops, 2.76. So again, the associated part, I usually just say find a reasonable domain and range, but for this, I wanted to make sure I remembered to talk about the fact that those are a pair. You can't just choose both separately. The minimum y values in your domain have to match the minimum y value in your range, and same thing with maximum. Okay. Interpret the slope of your model. Okay, so I'm not going to type this out, but I will say it. So we've got a slope of 0.13. And remember, that's like a change in y over change in x. So change in reaction time over change in time spent weightless. So if we, maybe I will type just a little bit up on this. If we think of that as a fraction, slope is always a fraction, even if it's not written that way. We can say that the 0.13 is the change in reaction time and the 1 is change in hours spent weightless. So my interpretation, a lot of times I'll say explain in the context of this problem, means the same thing as interpret, is that for every additional hour spent weightless, the astronaut's reaction time increases by about 0.13 seconds. So that's the slope. And hopefully these questions are not giving you any trouble to answer. This is the same kind of stuff that you were answering in previous sections. It's just now we have a technology piece that finds the model for us. Okay, next thing we have is interpret both intercepts of the model. So the y-intercept is easy to get. The y-intercept is 0.16. Okay, and remember, I want you to interpret both coordinates. An intercept always has two coordinates, an x and a y. One of them will be 0. Don't forget to include that information. So 0 is hours spent weightless and 0.16 is reaction time. So this, I would say, is telling me that before the astronaut starts his time weightless, his or her time weightless, the reaction time was 0.16 seconds. For the x-intercept, we actually have to do a little bit of work. So here, this is, okay, I'll even type out math for you. So we're setting this thing equal to 0. We want our y value to be 0 if we're looking for an x-intercept, or in this case, an h-intercept. So in this one, we just need to subtract 0.16 and then divide by 0.13. I've got my calculator even, a little bit bigger than 1, and it's negative. Okay, so 0.16 over 0.13, about 1.23. So that intercept is about 1.230. And again, both coordinates, that's important to me. And you want to explain both of them as well. So this one says, oh, hold on, I forgot a negative sign. That makes a huge difference. If it's been little over -1 hour spent weightless, the reaction time is 0. I think here what we're seeing is that we're getting outside of our reasonable domain. We said that this model doesn't really make sense if h is less than 0, and this is definitely an h less than 0. And it is legitimate for you to say that when you're interpreting. Part of modeling is making some judgment calls about things, what's reasonable, what's not. And this definitely doesn't seem reasonable. I don't see why his reaction time would continue to decrease if we went back before the weightlessness started. So if you're asked to interpret the intercept and it's not reasonable, you still give the intercept. You can say what it means. This would mean that 1.23 hours before weightlessness, the reaction time was 0. And then please say, this is not reasonable. This is outside of a reasonable domain, or something of the sort. Okay, one last question. I think one. Yeah, one last question. According to our model, what is the reaction time of an astronaut who's been weightless for 3.5 hours? So once again, I'm wanting you to just answer the same types of questions you were in earlier sections. So this is just saying we want t of 3.5, which, oh, I tried to make it pretty in green. Let's see if we can try again. Okay, according to our model, should be roughly 0.13 times 3.5 plus 0.16, which according to my calculator is about 0.45, 0.46. Hold on, let me see if I type that in right. Plus, nope, not quite. 1.6. Okay, there we go. What is it doing? 0.615. Okay. So 0.615. And then what is the reaction time of an astronaut who's been weightless for 3.5 hours? So this should be reaction time in seconds, so 0.615 seconds. Okay, so those are the kind of things I'm going to ask you to do. There's one at the end that's a little trickier. You make a couple of models and then try and put them together. So if you get stuck, post in forums and such, but this should get you a pretty good start, I hope. All right, thanks for watching.